Welcome back to Geometry Chapter 8, Section 7 in this book. And we've been talking this whole chapter about similar shapes. Things that are the same shape but different sizes. They can be bigger or smaller, but they have the same shape but they're a different size. They are not congruent. This is the last section, 7.8, and we're going to talk about dilations. And when you hear that word dilation, you think about when you go to the eye doctor and they put drops in your eyes and your pupils get real big. Well, that's what it has to do with things getting big or small. So if it could get bigger and it's called an enlargement, it could get smaller and it's a reduction. Now, I'm going to explain what this drawing means first and then I'll come back up to that. Okay, so here, remember, blue is the original, red is the image, the pre-image and the image. So I have this blue figure and then I have the red one that's just like it but smaller. So this is a reduction. And we could draw lines through them to what you might have learned in art class, what would be called the vanishing point. And you learn how to do this in art class to do perspective drawings, where things look 3D instead of squished flat. So some of you are artists and already know about vanishing points and how to draw perspective drawings. But you can draw lines through the vertices to the vanishing point, and you can measure how far it is from the vanishing point to the image or pre-image. It's 3 units to the image and 6 to the pre-image, to what we started with. So we could figure out the scale factor, how much it's been blown up or reduced, by figuring out the K, the relationship, the proportion of these two things. And so the distance from the vanishing point to our original is 6, and the distance from the vanishing point to our image is 3. So if we reduce that, 6 over 3, I did it backwards, I flipped it. You know I tend to do that sometimes. Let's pretend like I did not do that. Whoop, whoop, whoop. 6, 3, there we go. Miss Dyslexic just felt like that needed flipping. Okay, so if you reduced it, it's 1/2. So the image is 1/2. So we knew that we write this, while looking at it, we knew it was a reduction. So we know the smaller number goes in the numerator and the larger number goes in the denominator, because our image was half as big as our original. And this scale factor is called K. And if K is greater than 1, it's an enlargement. If K is less than 1, it's a reduction. K is less than 1, this is a reduction. Alright? So now this one. Here we have our pre-image is the little blue one. Our image is the big red one. So this one first, and then we made that one. The distance from C to the original is 2. The distance from C to the image is 5. This one is getting bigger. So I know the bigger number goes on top. 5 goes on top, 2 on bottom, and that's really already reduced. So that's fine for the K. But if you just want to make it into a mixed number, you can say that it's 2.5 times bigger than it was. Sometimes that's easier to think about than 5/2. Alright, so here's one. Blue is original, red. So is this an enlargement or a reduction? It's a reduction. It got smaller. Distance here is 2, distance here is 3. Because it's a reduction, the smaller one goes on top, the bigger one goes on bottom, and K is 2/3. It is less than 1. It is a reduction. Okay, how about this one? Here's our original, here's our image. So it got bigger. It's going to be an enlargement. The distance here is 2, the distance here is 1. 2 goes on top because it's an enlargement and 2 is bigger than 1. K is 2, it's twice as big. Now the last thing they showed us was they did some image and pre-image and image on graph paper. You really need to look at the book because somehow mine's off. Those are not really supposed to be overlapping like that, but this is the basic idea. If we are told that the K value is 1/2. So this is our original. We're making this K value. It's going to be half shrunk down. And if you take the original points that go with the original, so like this is A and it's 2, 2, this is B and it's 2, 6, this is C and it's 2, 4, and that's D and it's 6, 4. So that's what our original points are. If we want to find these, we look at our K, and our K is half. If we have half each of these, it will give us our new points. 2 divided by 2 is 1, 1, 6 divided by 2 is 3, 2 is 1, 2 is 1, 4 is 2, 6 is 3, 4 is 2, and those are our new points for our reduction, and we can get them by applying K to our original points. So if you can think of it as multiplying. If you multiply 2 by a half, you get 1. If you multiply 6 by a half, you get 3. Alright, so I think that's pretty easy and interesting and fun. Be sure to study all the example problems. Be sure to do your homework. I love it on page 511 where they have a flashlight that shows a spider on the wall. We got one of those. It didn't look like that. It was a Spider-Man Happy Meal toy that we got a long time ago. And the boys would take it and turn off all the lights in the schoolroom and shine on the wall, and there'd be a spider on the wall. It was very fun. Anyway, math is great. Come back for chapter 9 and we'll learn more. Yay!